Hi, this video is going to be about culture medium in biotechnology. My name is Ricardo Fernández Gasca, and this project is produced for the class of Design of Experiments given by Professor Hector Rincon. Well, first of all, we are going to define what is a culture medium. A growth medium or a culture medium is a solid, liquid, or semi-solid designed to support the growth of microorganisms or cells. Different types of media are used for growing different types of cells. The two major types of growth media are those used for cell culture, which use specific cells type derived from plants or animals. This is the one in the image of the left. And microbiological culture, which are used for growing microorganisms such as bacteria or fungi. That is the one in the middle. We have in the right some examples of medium how you can buy in some specific stores. Well, the most common growth media for microorganisms are nutrient broths and agar plates. Special media are sometimes required for microorganisms and cell culture to grow. Well, a good example of these media, the growth medium, is the word used to make beer. The growth is the image in the left, and it's the media to do the beer that we know. The wort contains all the nutrients required for just growth, and under anaerobic conditions, alcohol is produced. When the fermentation process is complete, the combination of media and dormant microbes is ready for consumption, so it's now the beer. We are going to see a little video, time-lapse of Bacillus cereus growing. In this video, we are going to see how the medium is used in order to grow bacteria and then analyze it. This is a time-lapse, so it's not the real time. This is accelerated time, so we can see how it appears in the medium. So that's how it's used. We can see all the bacteria in the sites. That's the way the medium works. So in the topic of our class, we are set to do this example. A bacteriologist is interested in the effects of two different culture media and two different times of growth of a particular virus. Here she performs 6 replicateds of 2x2 design, making the runs in random order. Analyze the bacterial growth data that follows and draw appropriate conclusions. Analyze the residuals and comment on the model adequacy. Here in the bottom we can see the table where we see the two different times and the two different culture medium. We can see that there is two different culture medium and times like one smaller than the other, and all the replicated. So in our design of experiments we present this table where we can see the two factors, the time and the type. The time with the minus is represented by the time with 12 hours, and the time with a plus is the time with 18 hours. And the type, the minus is the type number 1 and the plus is the type number 2. That doesn't mean that one is bigger than the other, but it only means like a differentiation of two types. So we can see a replicate and we can see the total. So with this table we are going to start working on an Excel sheet. So here we go. So here we are in the Excel sheet, and we are going to do this example. We are trying to fill this square with the effects. We can see here is the negative side, and here is the positive side. Here is the positive of A, here is the positive B, here is the negative B, so this is the standard. So here the minus it's equal to this one, the 1. So here is 140. Then A, when A is positive, so we set it the time. So it's 2, 3. Then when the B, when time is the negative 1 and the type is the positive 1, we say it's V. And then the interaction, or what we call when both are positive, it's 192. So we are going to estimate the contrast and then the effects of each one. So we can fill this one with, okay, so 1 it's 140. Then A it's 223, then AV it's 192, and V it's 156. Okay, so the contrast we can estimate it as, for example, for A, we can estimate the contrast as AV minus V. So we will do AV minus V, then plus, and so now it's A minus the number 1. So here's how we do. That's the contrast between the A's. So we can estimate this contrast. Then with the V, it's the AV minus A in this time. So it's AV minus A, and then plus, and it's V minus 1. So it's V. Oh, sorry. So it's V minus 1. Okay, so it's not exactly 1, but it's like. So we get the contrast. It's not significant if it's positive or negative. Well, it's significant, but it's not always positive. So here's the answer. And then for the interaction effect,
AD minus V, AV minus V, sorry, AV minus V, and then it's minus, and it's A minus 1, so it's A minus 1, okay? So we get this, and for the effects, we have this formula that it's the contrast multiplied by 1 over 2 to the n. So here our n it's 6, so the effects it's this times a parenthesis, and we put the fraction 1 over 2 to the 6 plus times 6. Oh, so we have the effects. We use the contrast and the effects in order to then do the ANOVA, because as we can see, here's we have all the effects, and now we can do the ANOVA table. So here's our ANOVA table. In this ANOVA table, we are trying to see which effects have a significancy in our process. So here we go. Okay, so we are now in this ANOVA table, and I already put the different formulas. So here, in order to get the sum of squares of each, we use the contrast squared, and we divide it by 4 times n, and n in this case is 6. Then for the total, we use the formula that we use always in the ANOVA, that it's the sum of squares of all the data, and then subtract. We will subtract this number. This number is the sum of all the data squared, not the sum of squares, but the sum of all the data squared, and then divided by 4 times n. And in this case, it's 6. So, and then the degrees of freedom, it's all the data minus 1. So in this case, we have all these 6 replicates and 4. So it's 4 by 6. So it's 24 minus 1. It's 23. So the degrees of freedom of the error are the degrees of freedom total minus the ones of the source. So then we are going to do the mean squares, and the mean squares are just the sum of squares divided by the degrees of freedom. So we can just take it, and we have now this sum of these mean squares, and then in order to get the f, we just do the mean squares of each divided by the mean square of the error. So we get it, and this we get this f calculated, and then to get the f ANOVA, it's so here in order to get the f ANOVA, we use this formula, the distribution of, okay, and then we use with a 0.05 of probability, then the degrees of freedom and the degrees of freedom of the error. So we are going to lock this one in order to drag. Okay, so we get the ANOVA of all of it. And so as we can see, in our analysis, we get that f calculated it's bigger than f ANOVA in source A, that as we know is the time, and source AV, that we know that is the interaction between the type and the time. So with this we can conclude that A and AV are significantly. So now we are going to do what we asked, that it was to get all the more analysis. Well, so here we have this table is the regression model table. We have the V0, V1, XA, V2, XV, V3, XAV. What it means, everything of this, it's V0, it's like the intersection of our line, and then this is not it's actually a line, but V0 it's the rate total divided by n, and it's the number of data, so it's 24, so it's an average. Then for V1, V2, and V3, it's only the effects divided by 2 in all cases. And then we fill this table with all the data, and here in the data we have
the first table we have transposed in order to have it this way, so we can evaluate it, if the expected with the data we can get a residual. So the expected is, oh, also these numbers, the -1 and +1, are for these first 6 data we have -1 because here we have the time it's minus and type is minus, so we put a -1 when it's minus and we put a +1 when it's plus. So the first 6 have minus minus, the next 6 have plus minus, the next 6 minus plus, and the last 6 have plus plus. And with the interaction, if we have minus minus, we have plus, and then if we have, well, here we have a little mistake, but if we have plus minus, we get minus, and if we have plus plus, well, we get plus. So now we are going to just follow this line, so it's this plus, no, sorry, yes, sorry. So it's this plus parenthesis this times this, okay, and then plus this, no, sorry, and parenthesis 2, okay, this times this, and then plus this times this, okay, and then we have the value that is expected. We can see that it's close, but it's not close enough, so so we just do the residual, that it's this minus this, yes, okay, and we get the residual. We can only drag because that's why I put all the values, even though it's the same, so I can drag them, and we can, okay, so as we can see, we have almost the same data because we are evaluating the same. What is not the same is the data, so we will see if the residuals, how it's, so then we have our residuals, and with these residuals we can do an analysis of the residuals and the regression model adequacy. Well, so for the last of this example, we are going to do a probability test, a residuals probability test. So this is when you have the residuals and you get a probability when you place in order. So here's the order. We order with this order, and then we get the probability, which is the place minus .5 divided by the number of data. So we get the probability, and then we just take these two and then do a dispersion line, and we get this probability versus the residuals. And as we can see in this graph, we can conclude that it follows the model, because if we draw the line, we can see that it's actually a line. It's some data like here -1 that doesn't fit exactly, but it actually follows a normality. So this normality test is good, and we can say that with this model we can get this the data correctly. So as a conclusion, we can see that if someone asks, you can say that the most important thing is the time in this example, because the time is what makes a bigger difference, as we can see, because it's 1:15 and then it's 18 only, the interaction. And actually the interaction between A and B, it's this number, it could be bigger. It's big because of the big difference between the time small and time bigger. So the time is the thing that actually modifies the result. So if you have to choose between the two types of medium, you should choose the one that you prefer, like the cheapest or whatever. So thanks for watching, and